Hi guys, it's your science teacher here, back with another video. This time I'm going to go through the whole of the Activate 1 topic, which is acids and bases. So without further ado, let's get into it and let's get started. Let's start off this topic looking at the differences between acids and bases. So an acid is anything with a pH of less than 7. And the word acid actually comes from the Greeks, who created this word that comes from the meaning of taste sour. And that's actually what scientists used to do back in the day to discover new acids. They would taste it, and if it was sour tasting, then it was acidic. And the opposite of what an acid is a base. And this is anything with a pH greater than 7. And down here I have a pH scale. And this pH scale goes from the strongest acid, which is pH 0, to weak acids, which have a pH of around 5 and 6. Then we have our weak bases, which have a pH of around 8 or 9. And then we have our strong bases, which have a pH of 13 and 14. Now, you may have noticed on this pH scale, it actually uses this word here, alkaline. And what it means to be alkaline is it just means that you are a base that is soluble. This just basically means it dissolves in water. And another thing you may notice from the pH scale is anything that has a pH of 7 is neutral. But you may be wondering, where does this pH scale actually come from and what use is it? Well, we actually work out the pH of acids and alkalis using what is called universal indicator. And this changes the colour of my acid or base into a colour which matches the pH scale. So over here we have our strong acids. And you can see in the middle we have here a neutral solution. And over here we have our strong. In fact, you can actually use universal indicator as well, which will go to the colours on the pH scale, and you can easily read off to find out the pH. If you want to work out even more accurately the pH though, you can use something called a pH probe. And a pH probe is probably the most accurate way of determining the pH. It gives you a pH to the nearest 0.01 here, whereas obviously on here we can only use the pH scale going up in 1, 2, 3 and 4 usually. So a pH probe is much more useful in determining accurately the pH. And if you're not bothered in working out the actual pH and just whether you have an acidic or a basic solution, what you can actually use is litmus paper. And there's two types of litmus paper. There's red litmus paper and there's blue litmus paper. Now, if the red litmus paper is placed in an acid, it will just stay red. Nothing will really happen to it. However, if the red litmus paper is placed into a basic solution, it will turn blue. Now, the other type of litmus paper is blue litmus paper, and if blue litmus paper is placed in an acid, it will turn red, and if it is placed into a base, it will turn blue. And that's what this diagram down here is showing as well. Now, when working with acids and bases, we often have to be careful as they come with warning symbols. But we actually need to know what these warning symbols mean when using the acids and bases. The first is this exclamation point. And when we see an exclamation point like this means that I'm going to be working with something hazardous. And a lot of the times we will see that on our acids or bases. The next one is a little bit rarer than hazardous. This means that it is a health hazard. And because it's a health hazard, you probably don't want to breathe it in. The next safety symbol, the skull and cross, that stands for a toxic substance. And you definitely don't want to be ingesting anything that is toxic. Next one is a danger to an environment. That's why you don't throw your substances down the sink. Your teacher will teach you how to dispose of acids and bases safely. And then finally, this safety symbol here stands for corrosive. And corrosive basically means that it can cause our skins to burn. And that is why it's important when we are working with acids and bases, we always use our safety equipment. Maybe your teachers will want you to wear gloves, but they will certainly want you to be wearing safety specs when working with these acids and bases. Now, sometimes when you are given a chemical, you are expected to just know whether it is acidic or whether it's basic. That is because there are some well-known acids and some well-known bases that we will use a lot. For example, the well-known acids we use in a lab are usually going to be hydrochloric, sulfuric, and maybe some ethanoic and some phosphoric acid. These are the main ones that you're going to encounter in the laboratory. There are also a few well-known bases that you will be using, and they are usually going to be metal oxides and metal hydroxides. But I said there was also some household acids and some household bases that we use. So let's have a look at some of them. So some acids that you are likely to encounter around your house. I bet you didn't know that orange juice was actually acidic. In fact, every citric fruit will be acidic because it contains something called citric acid. Also, another household acid that you are likely to come across is vinegar. Vinegar actually contains ethanoic acid. And there is actually an acidic substance that flows through our veins. Blood is actually mildly acidic as well. What about bases? Which bases are we likely to encounter on a day-to-day basis? Well, there's soap, which we find all over our house. There's bleach. Toothpaste is actually basic as well. And we come into contact with loads and loads of different acids and bases all the time. But what actually happens when you have an acid and you mix it with a base? Well, you get a reaction called neutralization. And in all neutralization reactions, you make the same two products. You're always going to make a salt and you are always going to make water. Now, naming this salt is the trickiest bit of this topic, maybe. And you need to know a few rules. It always, the first word of the salt is always the metal. And then the second name of the salt comes from the acid used. If you use hydrochloric acid, you make a chloride salt. And if you use sulfuric acid, you make a sulfate salt. So let's look at what this means then. Let's do an example. So here I have hydrochloric acid, and I'm going to react my hydrochloric acid with some sodium hydroxide, a common example of a neutralization reaction. In fact, all of these neutralization reactions are exothermic as well, meaning they will give out a little bit of heat. So if I add these two together, I should see that my solution gets a little bit warmer as well. And naming this salt is the hardest bit then. So the first word comes from my metal, which is sodium, and the second bit comes from the acid I've used. And because I've used hydrochloric acid, I've made sodium chloride. If I was using sulfuric acid, I would make sodium sulfate. Now, what happens if you want to collect this salt later? Well, you can use a technique called crystallization. And crystallization works by evaporating off the water and leaving the crystals on the side, and you can end up with some wonderful blue copper sulfate. I know my year 7s did this and absolutely loved it. So make sure that if your teacher hasn't done it with you, ask them about making some copper sulfate, and I'm sure they will love that. All right, thank you for watching this video. And remember, if you did, drop it a like and subscribe to the channel.